Hello everyone. In this video, we are going to discuss about complex numbers in example 1 from the chapter 4 complex numbers and quadratic equations class 11 maths. Let us consider this equation x square plus 1 is equal to 0. When we take this plus 1 to this side becomes minus 1, so we can write x square is equal to minus 1. If x square is equal to minus 1, x will be equal to square root of minus 1. See, we know that square of every real number is positive. That cannot be negative. So, square of every real number is non-negative. If x is a real number, then its square must not be a negative number. But here, x is not a real number, right? Because its square is a negative quantity. So, this equation has no real solution. Now, let us denote this square root of minus 1 by the symbol I. That is, I am taking square root of minus 1 as I. Okay, see, I is equal to square root of minus 1. When I take square on both the sides, we can write I square is equal to square root of minus 1 whole square. Square root of minus 1 whole square is actually what? Minus 1. Okay, so you see, x square plus 1 is equal to 0. That means x is equal to square root of minus 1. Square root of minus 1 is actually what? I. Square root of minus 1 is I. So we can write x is equal to I. Okay, so you see x square plus 1 is equal to 0. In this equation, x is the solution. So here x is equal to I. So we can take I as the solution to this equation x square plus 1 is equal to 0. You see, a number of the form a plus ib, okay, where a and b are real numbers, is defined to be a complex number. So the number of the form a plus ib, that is actually defined to be a complex number. Here a is a real number, b is also a real number. So if you consider this number 2 plus I3, see 2 plus I3, it is a complex number. Here a is equal to 2 and b is equal to 3. They are real numbers. And this is of the form a plus ib. So this number 2 plus I3, that is a complex number. Any number of this form a plus ib where a and b are real numbers, that is actually called as a complex number. So here 2 plus I3, this is of the form a plus ib. So this is a complex number. Okay, similarly, if you consider this number 4 plus I into minus 1 by 11. So here you see this is of the form a plus ib where a is equal to 4 and b is equal to minus 1 by 11. Both are real numbers. See, the complex number is represented by the letter z. So we can write z is equal to a plus ib. A plus ib is a complex number. A complex number is represented by the letter z. So we can write z is equal to a plus ib. Here a is called as the real part of the complex number. It is denoted by REZ, real part of the complex number z. And b is called as the imaginary part of the complex number. So b can be denoted by IMZ, imaginary part of the complex number z. Okay, so complex number is represented by the letter z. So we can write z is equal to a plus ib. This a is actually called as the real part of the complex number and this b is actually called as the imaginary part of the complex number. That is, for example, if you consider this complex number z is equal to 2 plus I5. So here this is of the form z is equal to a plus I into b. Here a is equal to 2, b is equal to 5. They are real numbers. So this is a complex number. So here the real part of the complex number is equal to 2 because a is called as the real part of the complex number. And this b which is with the term I, that is actually called as the imaginary part of the complex number. So here the imaginary part of the complex number is 5. Now you see, if we consider two complex numbers, z1 is equal to a plus ib and we are considering another complex number z2 is equal to c plus id. these two complex numbers z1 and z2 are equal if this A is equal to C and B is equal to D. That is, real part are equal and imaginary part are equal. If it's so, then this two complex numbers z1 and z2 will be equal. Okay, so two complex numbers z1 is equal to a plus ib and z2 is equal to c plus id are equal if a is equal to c, real parts are equal, and if b is equal to d, that is imaginary part are equal. Now, let us discuss this example 1. If 4x plus I into 3x minus y is equal to 3 plus I into minus 6, where x and y are real numbers, then find the values of x and y. That is the question. Here, two complex numbers are said to be equal. Two complex numbers are given to be equal. 4x plus I into 3x minus y, that is a complex number. 3 plus I into minus 6, that is also a complex number because these two are of the form a plus I into b. Okay, so you see these two are complex numbers and these two complex numbers are given as equal. It is said that this x and y are real numbers and we want to find out the values of x and y. So we already know that if we consider two complex numbers z1 is equal to a plus ib and z2 is equal to c plus id, these two complex numbers are equal if a is equal to c, that is real parts are equal, and b is equal to d, that is imaginary parts are equal. Okay, so here you see we have the first complex number z1 as 4x plus I into 3x minus y. And we have the second complex number z2 as 3 plus I into minus 6. These two complex numbers are equal. That means their real parts are equal and their imaginary parts are equal. So real part of z1 is 4x. It is equal to the real part of z2, which is 3. From this we can write x is equal to 3 by 4. Okay, so we got the value of x. Similarly, these two are equal if their imaginary parts are also equal. So imaginary part of z1 is 3x minus y. That will be equal to the imaginary part of z2, which is minus 6. Okay, see, from this we can write I am taking this minus y to this side and minus 6 to this side. So 3x, I am taking minus 6 to this side becomes plus 6 is equal to, I am taking minus y to this side becomes plus y. Okay, so we can write y is equal to 3x plus 6. Okay, so this is equal to 3 into, what is the value of x? 3 by 4 plus 6. Okay, so y is equal to 3 into 3, 9 by 4 plus 6. Okay, let us do the cross multiplication. So 9 plus 6, 6 means 6 by 1. No, so 1 9s are 9, 6 4s are 24 divided by 4 into 1, which is 4. So this is equal to 33 by 4. Okay, so value of y is 33 by 4. Okay, so we got the value of x as well as the value of y. I hope it is clear to you. Thank you.